Okay, so Newton's formula is over the 17th century. Isaac Newton showed that the height h of an object at time t after it has been thrown with an initial velocity v sub 0 from an initial height of h sum 0 satisfies the formula the following. Pretty much what that means is, well, guys, how do I move that? There we go. If I throw something up into the air, it potentially is going to meet a what? What does it mean? It's going to meet, if you throw something up, it's going to meet at, it's going to, at a vertex, and then what's going to happen? It goes down until it hits what?
The ground.
The ground, okay? Or, say for instance, there's water at ground level. Could you go below sea level? Yeah, so those things are options. Okay, where a g is the acceleration due to gravity near the surface of Earth, g is approximately 32 feet per second, or 9.8 meters per second. Okay, here's the question. The height h in feet of an object shot from a height above the ground is given by the following formula. This guy right here. It says t has to be greater than or equal to 0, where t is the time in seconds and h of t is the height in feet. So I want you to imagine, like, why, with me throwing a ball or anything, with me throwing a ball, why can t not be negative? T represents what? You can't go back in time because t represents seconds. Okay, so your x value is what is inside your formula. T is inside my formula, so what does x represent? We just circled it. Seconds. And then it says h of t is the height in feet of whatever you're throwing into the air. So y equals what? Bless you. Height in feet. FT. Height in feet. Okay, on this side, it says GC. Does everybody see that? It's because some of your test is going to be graphing calculator and some of it's going to be not graphing calculator. So for the GC questions, that means we are going to be using a graphing calculator. We're going to plug this guy into y equals right now, and I'm going to do that with you guys. The one that is circled.
But we do t or we do?
There we go. And this one. We don't have t. We only have x. So let's go to y equals. Clear out anything you have. Everybody, we should be at y equals. Clear out anything you have. And how do you type that in? Okay. Negative 16 x. Let's put that over here. X squared. Then what? Plus 64x, because we don't have a t, so 64x, and then plus 190. What do you click? Graph. Yours probably will not look like this. Some of you have the original table that looks like this. Okay, because somebody had your calculator last class. Here's the thing. This last number tells you where it starts on the y-axis. So after 0 seconds, how tall off the ground is this ball or whatever we're throwing already at? It's already at 190. The table that's currently on my graphing calculator only goes up to 10. Do you realize that? It only goes up to 10. And this tells me it starts at 190. So that means I'm going to need to be going up, down, left, or right with my picture. Up. Very good, Ethan. So we are going to go, this is new, we're going to go to window. Everybody click on window. Do you see where it has the X moving left and right? Okay, so do I mess with the X's if I'm moving left and right? Not on this example. I need to go what direction? Up. So that's going to be the Y max or the Y min? y max, and it starts at 190, so you want to go higher than a lot higher than 190. What do you got? Okay. And the last thing is the y scale is going by ones. I need you to think about it. If you're going from negative 10 to 300, should you be going by ones? What do you want to go by?
40s?
I'm going to go by 50s, but you can go by 10s or 100s or anything like that, but I'm going to go by 50s. So right now your window should say negative 10, 10, 1, negative 10, 300, 50, 1. You never mess with the X, RES, okay? You have to go down to 0 because we have to see where it hits the ground. So that's why I always put it at negative 10. I would move that to negative 10. You can make it more, like you can do negative 50 or negative, but it needs to be underneath the 0 value so you can see it. Yep, that's a good question. Okay, go ahead and click graph, and now it should look like this. I didn't hear you.
My X is at 0.2.
At 0.2, the X min.
No, it's that. Like the triangle X.
Yeah, we don't mess with that. Oh, you just click graph. Okay, at this point, the question says, graph the function, find the vertex. Is the vertex a max or a min? It is a max. Who remembers how we figure out the max on a graphing calculator? Second trace. Good, Cooper. Second trace. And it's a maximum, so what number? 4? Left bound. Am I left bound to the vertex? Yes, so what do you click? Enter, and then right bound is where?
Down.
Right. Somewhere over here. I'm already on the right bound, so I'm good to go. Once you're on right bound, what do you click? Enter, and then enter again. Okay, so that is going to be your vertex. You're going to fill that in. 2, 254. Can anybody explain to me what 2, 254 means? In words. What are we talking about? Right here. X is seconds and Y is height in feet. What does 254 mean?
X seconds and height is 254. So it goes 254.
Yeah, go ahead. Cooper's got it too. After what? Go ahead, Cooper. After what?
After 2 seconds is 254.
Yep, and that's the peak because it's a vertex. So after 2 seconds, it's 254 feet in the air. So I can already answer B. B says, how high is the object after 2 seconds? How high? 254 feet. And that's the maximum height. Okay, then it says, how high is the object after 5 seconds? This is new. To find seconds, first off, is seconds the X value or the Y value? Look at your labels. The X. To find X, a random X, we just go to second trace again, but this time it's a value. So everybody click on second trace. And this time it's a value, so what number? 1. And X equals what? 5, because it says 5 seconds. Click enter. 110, and what's the label? Feet. How do I figure out? It says, how high is the object after 8 seconds? Where do you go? You do the same thing, so how do I get there? Second trace 1, and then it says X equals, and X equals 8, so click enter. It is negative 330 or 322 feet, but that can only be true if what? If what happens with the ground? Like, yeah, it goes below sea level. So if the ground is flat and it does not go below sea level, the question below says, what does this tell you?
I should just hit the time.
It should just hit the ground, like it's on the ground. Yep, so it says, what does this tell you? The object is on the ground. If it asks you how high the object after 8 seconds is, I still want you to find that information, but only when you have a graphing calculator. Like when you do it by hand, it won't ask you those. You won't do that. You'll just look and it will say, you'll see, well, at 6, it's actually already passed, so it would be 0 on the ground. Okay, when does the object hit the ground?
6 seconds.
How do you know?
0.
Okay, we can use second trace and we can do 0. You guys remember that? So everybody, why does the left one, this one right here, not pertain to our information? Right, where did this ball start? 190 feet. So everything left is irrelevant. Do we understand that? So it's getting thrown right here, and where it hits the ground is going to be the right 0. Are we good so far? Okay, so to get that 0, you go to second trace. And it's when it hits the ground, hitting the ground is a 0, so what number?
0.
2, yep. And then look where you're at. It says left bound's at 8. Where's 8 on your graph? 1, 2, 3, 4, 5, 6, 7, 8. So to get back over to my parabola, where are you going to have to arrow? Left. So let's arrow left until I see it. Now we are on the left side of that 0. So when you're on the left bound, what do you click? Enter. And then you go right bound, which right bound is below, and you might not be able to see it. So make sure you just arrow below until, if you can't see it, that's fine. Click enter, and then enter again. And I get 5.98434, which could just be rounded up to what? 6. So the x-intercept that matters up top is 6. And then it says, when does the object hit the ground? What would you say in words? When means time.
6 seconds.
After 6 seconds.
I put 6 seconds.
Okay, let's use the logic we already know. When does the object reach its highest point? When means time again. 2 seconds. It meets its highest point. And then what is the object's maximum height? 254 feet.
I like to re-ask the question.
They do. So you kind of have to think about what everything means. Okay, to label it, 1, 2, 3, 4, 5, 6. I know it's going to meet the ground at 6 seconds. And then 254, I'm going to put somewhere up here. So that's your vertex. Right 2 of 254. And then connect your points.
So you want me to 3 points still?
Yep.
Okay.
Can you give me an example that where this particular parabola would not fit? Like, can you give me an real world example?
Wait, what?
Where a real world example where this wouldn't work? Probably like skydiving or cliff diving. Could you increase by almost like 60 more feet in the air before you jump?
You can increase
No, but you're still going to make a parabola, but you're not, yeah, you could increase a foot, but here we're increasing 60 feet, so that's not going to happen. This, in my eyes, it's like somebody standing on top of a rock that's 190 feet above ground and throwing a ball into the air.
I was thinking